Good morning. I'm Chris Teutsch, Forage Extension Specialist at the University of Kentucky's Research and Education Center in Princeton, Kentucky. It's a pleasure to be back in Virginia talking at the 2025 Virginia Winter Forage Conferences. The title of my presentation today is Hay Quality, Defining, Quantifying, and Supplementing. This presentation is going to be broken up into 5 parts, so if you're interested in the next part, just go back to the playlist and click on the second part. I always like to start out when I talk about hay quality and ask people, what does it mean? What does hay quality mean? We throw a lot of terms around trying to quantify it. Crude protein, neutral turgid fiber, acid turgid fiber, in vitro true digestibility, NDF digestibility, and the list goes on and on and on. And every year we add more terms trying to get at what hay quality is. But to me, the essence of hay quality is the ability of a forage to produce a desired animal response. And that's a moving target, right? Because what's a quality forage for a brood cow is not going to be a quality forage for a dairy cow or a pleasure horse. So understanding that there's a range of requirements for different animal classes is really important, and that's what this table shows. Even within an animal class, the nutrient requirements of a particular animal can be quite different depending on the stage of production. So for example, a beef cow has a crude protein requirement of 7 to 8% when she's dry, and a nutrient and total adjustable nutrient requirement of 50%, versus a 10 to 12% crude protein when she's lactating, and 60% TDN when she's nursing that calf. So we need to define what level of forage quality or hay quality that we need for our particular operation, and that's a job that you guys have to do. You have to figure out what that target is. So if I have a brood cow operation, I don't necessarily need dairy quality hay for my operation. Matt asked me to talk a little bit about evaluating hay, and he asked me to talk about the organoleptic method, and that's a fancy word for sensory evaluation. So I look at that hay, I touch it, I smell it, and then I try to make an assessment of the quality of that hay. We'll often use hay scorecards like this one, and we'll look at things like maturity, were seed heads present. We'll look at how leafy it was. What color is it, brown or green? Does it smell a nice fresh hay smell, or does it smell musty or moldy? And then is there foreign material in that hay? And in December of 2021, an EF4 tornado hit our research station. It destroyed 59 buildings on our research station. And we're almost done rebuilding. We'll be done the end of 2025. But that tornado gave me a whole nother appreciation of foreign material in hay. There was construction debris everywhere. We walked over 800 acres of fields with 5-gallon buckets, picking up pieces of roofing material and boards with nails and so forth for 3 months in the winter of 2021. Not the highlight of my career, but I do have a completely new appreciation for foreign material in hay, and the reason we want it to be free of foreign material. What this method, this sensory method does not do is quantify the nutritional value of the hay. So I might be able to rank 2 hay lots and say hay lot A is better than hay lot B, but it doesn't allow me to look at hay lot A and say it's 10% crude protein and hay lot B and say it's 7% crude protein. That's kind of where laboratory analysis comes in. And laboratory analysis allows us to measure or quantify a whole bunch of different things. Dry matter, crude protein, acid, turgid fiber, and the list goes on. And we do this, for the most part, with a method called near-infrared spectroscopy. Near-infrared spectroscopy is a rapid, accurate, and precise method. About 90% of the samples analyzed in the United States are analyzed by near-infrared spectroscopy. It involves grinding the forage up and putting it in a small disc with a quartz glass in it like this. We put it into a machine. We shine light onto the sample and measure what gets absorbed and what gets reflected back. And from that, we can build equations that will predict the constituents in the forage that we're looking for the nutritional value. So the take home from this is that we're quantifying the nutritional value of the hay using this method. And that's important because then it allows us to compare the nutritional value of that hay to the requirement of the animal, and that tells us whether we either need to supplement that hay or we do not need to supplement that hay for that particular animal class at whatever stage of production they're at.